right, welcome to my awesome talk about this project called BusD. For anyone of you, for some reason, who don't know who I am, my name is Zeeshan Ali Khan, and I'm a bit of a nomad, now very much settled in Berlin, so it's a bit unlikely I'll move anywhere anytime soon, but might move at some point again. Yeah, my background is in C, long time C developer. I was a huge fan of this language. For those who know me for a long time, they know this is true. And I started with GStreamer project that you and GNOME. I was involved in GNOME for a long time. No longer so much involved in GNOME anymore directly, but indirectly I am. We'll talk about that in a bit. And there was this project called MIMO, Migo, a bunch of different projects in Nokia I was involved with, if you know about that. Basically just open source developer want the best for the world, and especially for open source world. And nowadays I'm a huge Rust fanboy. Those of you who know me, they know this as well. And they will think that this is what identifies me, but it doesn't actually, but yeah. So let's hear a short story, not a long one. I promise it's not too boring. There was a project called GeoClue. There still is, actually. It's still out there. And I rewrote the second version of it, and then after rewriting something, of course, you become the maintainer of that project. What this project is, if you don't know, it's a geolocation service, and it talks through other applications through a protocol called zbus. And it's written entirely in C. But the thing is, when I was maintaining it, I didn't have a lot of time towards the end of my maintenance time for last many years I was maintaining. And most of the reports I would get, issues, they were just crash reports. And I was just really, really tired of that. And at the same time, I became a sort of started becoming fan of Rust. So I was like, why don't we oxidize this, right? So at least I'll get rid of crash reports. 99.9999% of them. Maybe there will be some other issues, but at least no crash reports anymore, which is really, really boring to handle. So I was like, okay, but how do I use this zbus protocol? How do I do that from Rust? But let's first talk about what really is zbus, like if you don't know. It's an extremely efficient IPC protocol, at least it's meant to be. It's extremely efficient, it's designed to be. And it's used a lot in all kind of Linux machine, desktop, embedded, even servers, actually, that I found out recently that it's really, really used a lot on clouds. I didn't know about that. And it's used by things like systemd, all GNOME services, components, you name it, and also by KDE project as well, and many other desktops and systems that I can't name all in here. But it's more than just IPC. Most of the IPC you would see is like, they're usually about message passing. They create some kind of transports. They allow you to create messages as easily as possible and just transporting those messages. The parsing of those messages and all that, it's usually on you. Any kind of routing and all that is also usually not part of protocol, sometimes is. So typically it's a very high level, low level concept, IPC or RPC in general. But dbus is, it's not just a low level protocol for message passing, but also it provides you an API that we will have a look at in a bit. But on the low level, it still is very much message passing. So you can write low level and high level code with this protocol. On the high level, it's like a bunch of objects. They have object paths, just like it's designed after file system that you have for paths, and you can have a whole hierarchy of these paths. A lot of services have huge amount of them, so hierarchy comes in use there. So for example, in GeoClue, we have these kind of objects with these paths. There's one manager for each peer that talks to it. There's a client for it, and they can get different kinds of locations, and they have these paths for those locations. And each object can have one or infinite amount of, in theory at least, interfaces on them that provide the behavior for each object, different kinds of behaviors that they can support. And they are very dynamic, like that interfaces can come and go at any time, objects can come and go at any time. And the interfaces, how they define different behaviors through methods, basically. So you have, just like in programming language, functions that you call them. There's input and output parameters of those methods. And there's also a concept of properties, which is just like state of your particular object and interface combination. So in case of location, for example, you have latitude, longitude, and altitude associated with it. These are the properties of this interface of this object. Similarly, there is also signal, which is the other way around. If a service wants to notify someone of interested parties of any change, they broadcast a signal. But this is a pub/sub kind of thing that only people who are interested, clients who are interested, they get the signal broadcasted to them. And you can, there's a way to subscribe to specific signals. The dbus itself is based on a concept of a broker. That's the primary use case of it. You talk through peers through something called a broker that sits in the middle. It also implements some kind of policy, security policy, and it makes sure that everything is received to whoever needs to receive it. It has fancy features like if you make a call to a service, it will make sure that that service is started for you if it's not already running, and things like that. But this broker is also called the dbus daemon, or just simply we can call it the bus. And there are two kinds of buses. One is system bus, which is for things that are available throughout your system, such as like systemd services that they are all on the system bus. Some of them are actually on session as well, but mainly on system. And NetworkManager, modem manager, those kind of things that are common between all users of all sessions of all users. They are on the system, and the rest that is per user or for a specific session of the user, they are on this session bus. There is a bit of ambiguity of session bus versus user bus, but in essence, they are actually the same thing. Don't let Leonard tell you they are different, because he believes they are different, but in really they are not. They are the same thing on your system. Right now, if you check, you don't have any user bus, you have only session bus. I can guarantee you that. There is also peer-to-peer. Like you can do peer-to-peer with dbus, and people do that a lot, actually. There's nothing stopping you from that, but this is not the primary use case of it. The primary use case is through a bus. And there you lose a few features, like I mentioned, like starting a service and all that. That comes for free for you through the bus. And then you have to implement them yourself, obviously, but you can do it. Anyway, so I needed to rewrite a dbus service, right? For if I wanted geoclude to be oxidized. Oxidized is just a word to port something to Rust. So if I wanted it in Rust, I needed a dbus API, basically. And I was like, there must be a crate for it. Crate is a Rust word for libraries. So a library in Rust is called a crate. And I was like, there must be one. And there was one called dbus RS, or simply dbus. But it's a wrapper around a notoriously bad C library called libdbus. It's not nice, the API, and the wrapper shows that as well. Like it's just a wrapper around it, so it can't have a better API really, even though it's in Rust. So it is a big improvement, but it can't go too far because it's based on it. But there were also multiple issues. The API was overcomplicated and stuff like that. So I was like, what the hell do I do? And I asked at that time on Facebook, I went and I was like, Facebook was really cool at that time, so I was posting a lot there. So anyway, how do I instantiate this type, like this really long, really weird looking type that should give you nightmares? And I had to deal with this for this dbus RS. And I asked, can anyone help me with this? How do I do this? And one of my friends who was also into Rust at that point, he says like, that sounds really horrible. Why do you need to do this shit? I was like, well, what can I do? That's the API. And he wrote like, okay, someone will create an ergonomic API eventually, smiley face. And I didn't realize at that point that that someone might be me. So I was like, okay, maybe it could be me. So I started thinking of dbus from scratch in Rust itself, so no dependency on a C library. And several moons later, this is not C, this is moon. Sorry, the emoji doesn't make it clear. So yeah, several C's or moons later, I had something called zbus. And it's a new library. Well, it was 3 years ago, or 4 maybe, I think, by now. And the motto was to make dbus easy, and Rust at least. And the cool thing was that after several months, I was going really, really slow because it wasn't my full-time job. So old friend and old colleague, Marc-André Leroux, he joined in, and he needed that for his work. So he helped me a lot to get it across the line and to get a release out. You must be wondering what's with the Z. It's just a Z, come on. No comment. It's just a good, cool name, right? zbus sounds cool. The API is async first. The first version wasn't, but then I rewrote the second version. Also, a lot of hard work, believe me. And it's now the primary API is completely async. This is what people wanted. A lot of people were asking for it, so it is now. With a bunch of blocking APIs around it. So if you need blocking API still, for simple cases, it's exactly what you need, actually. You don't want to bother with async and all that shit. So yeah. And let's just have a quick look, like what am I talking about, what zbus is. It's like, it provides you this thing called macros in Rust that makes things super easy. I don't know if you have ever done any dbus programming, especially in C, but if you have, if you look at this and you compare it what you have to do to achieve the same thing, you will realize this is just godsend. This is as simple as it possibly can get in a strongly typed language. Like maybe in Python it could be simpler, but it's not. As far as I have been told, the Python dbus is not as simple as ours. It's not as elegant as ours, at least. Yeah, I think at the moment this is as simple as elegant at the same time as it gets to talk to dbus. This is a simple service that just exposes one method that says hello, and each time it increments a counter, and you create a connection and you expose it on a specific with a specific name on the bus, because names are how people can know where you are on the bus, how to connect to you, yeah, you give it a path which path this interface is on. You can have the same interface, like create multiple instances of it on different paths, actually, which is quite normal thing to do, actually. But in here we are only doing it one path, one interface, one method. It's easy, simple. The client side of it is even simpler. You just declare the trait, the behavior of it, like what is the method, what are the inputs, what are the outputs, in completely Rust syntax. So if you know Rust, this is a walk in a park for you. So yeah, it's just calling that method that we just defined previously on the other side, and yeah. Then zbus by now has become the go-to dbus crate in Rust, and people just use it, and it's like, I think, yeah, more than 10 million downloads by now, which is more than the dbus RS, by the way, which started actually 3-4 years before us. So that's, I think, a bit of an achievement. You would think like this is maybe my work is done here. Maybe I'll just maintain zbus now in my spare time and I can rest easy. I have a baby, I have a child now, small child, so maybe I can relax a bit. But unfortunately not. There is still work to be done. So not exactly. We still have the broker. So what about the broker? Well, the dbus daemon or the bus? How is that implemented? How is it that like? We currently have 2 major implementations that I know of. Maybe there are others that they are not very well known or used even. And the first one is dbus daemon, which is the reference implementation of the protocol. It moves exactly, it's the same actually project on GitLab, .free desktop. and any feature that is in the spec, that has to be also in the reference implementation from the start, and vice versa. But as you can imagine, as the spec is old, which is I think now 23 years old, something like that, this daemon is also extremely old. This code is extremely old C code. And that's why about 10 years ago or so, someone wrote another one, zbus broker. This is much better implementation. It's much faster, it's much more efficient, and also it makes a lot of use of the system D and all kind of fancy new features in Linux user space and kernel maybe as well. So it's pretty neat implementation that was done after. And that's Fedora uses it already, and actually all distros by now, the latest versions, as far as I know, they use that. But if they don't, then talk to your distro people why they're not using it. But they're all in C, that's how I started with like why I wanted to get rid of C. But thinking about it like in a more pragmatic way, is that really an issue? They're in C. Let's think about that a bit. Is the issue yes, and actually no as well. In terms of like where the first thing you think about C versus Rust is safety, which is what Rust has on C, right? However, if the code is really old and it doesn't get a lot of new features, and it's battle tested, it's used in all kinds of things like cars and servers and all that, as I mentioned. There are various products it's used in. So it has seen a lot of testing in the wild. So I wouldn't worry too much about the safety aspect of it anymore, especially zbus daemon. But the thing is, like, if it's so stable and it doesn't change, so that's also a problem, right? So it's not actively really developed a lot. New features, usually they are not taken. I don't know if there has been any new feature in the recent times taken in zbus daemon, but also in zbus broker, it's not so quite actively developed. There's a lot of feature requests that are just there. Either nobody replies or they get shot down even. So that's a bit frustrating if you want to go forward with time, because there are a lot of new features that we will talk about that are needed there, but they're not being developed. So but if that got fixed, let's say these projects started doing a lot of active development, then you lose all that safety that you have because it doesn't change anymore. So there's a bit of a dilemma. So it's a good thing it doesn't change safety-wise, but then if it does change, then it's not a good thing safety-wise. And it's hard to be excited about an old C code, especially something that has existed for 20 years and hasn't been really a lot developed recently. Especially new people who now come to computer science. There was a presentation yesterday about it that was talking about there's not a lot of young people in open source. There's mostly people like me, old people, or middle-aged. How would I say it? I don't know how I am. But it's for new people, it's hard to be excited about an archaic language when there is a better choice out there, or better choices out there, I would say, based on what is needed, right? Like it doesn't have to be Rust. It can be whatever modern programming language that has cool features. But going back to C, it's a bit hard to excite about. And that's why it's hard to get new contributors in, especially and also if you don't that you are not very active on taking new features and excited about new features as maintainers, then the new contributors wouldn't be excited either, and they wouldn't come to you with them. And then we, as I mentioned before, there are modern requirements that has to see some development, and that is not really happening. And if it is, when it is happening, it's extremely slow. Such as, like, for example, sandboxing. So we, in Flatpak, for example, we can't just allow people to just directly talk to the bus because there are services that need some protection, and we need to ensure that an app only and only talks to the services that it advertised for that, okay, I'll be talking to these services, and the user can be notified in a nice fashion that, okay, these are the services this app needs. For example, if it doesn't need location services, then it should never be allowed to connect to GeoClue, for example. So because of that, we had to have, well, when I say we, people who work on Flatpak, there's a project called XTG dbus proxy, which has seen a fair share of issues, and it's not even actively maintained, as far as I can tell. There's some new people who had to fix some really difficult bugs in this proxy thing, and the thing is that it's sort of a workaround, because what is needed is for the bus itself to be able to for the Flatpak to be able to tell the bus that, hey, this is a sandbox app, and it only should be allowed access to these kind of services, and you cannot have this kind of policy dynamically in dbus. So there had to be another solution on top that just works around this limitation, and this has a as I said, fair share of issues. Some of them are not even easily resolvable, so that's also a bit of a problem. So how about a new dbus broker which actually implements new requirements, basically addresses new requirements in a nice way, and also it doesn't suffer from the same problems, like it's entirely C code, and if you do new development, you can be fairly certain that you don't introduce most of the safety related issues that can come up very easily in C code. So we can do it in Rust, basically. But we do it in Rust, not Go or anything else, because we still want to be as performance as C, right? So that's why Rust. And also, if I'm doing it, then also there's another reason to do it in Rust. So let's first do an experiment. I decided, and I'd spent like just 2 weekends, like, let's see if I can even get a basic version working. And in 2 weekends, I was able to get a basic implementation done. Actually, my first idea was let's see if I can do it in 1 weekend, but then became 2 weekends. But still, it was fine, and it did all the basic stuff that a bus does already, and that's how a BusD project was born. It had a few different names in between. I couldn't come up with a nice name. I think BusD is fine, so I settled on this. And you might ask, like, why didn't I think about oxidizing dbus daemon, or also maybe dbus broker itself? It's a good question, but I like to do things with first principles thinking a bit, especially after I did zbus from scratch. I got into this kind of way of doing things, because there is a huge benefit of this kind of thinking, where you start from scratch, don't assume much, assume as little as possible, and break your assumptions into smaller pieces, and then try to, even in your solutions, take as little assumptions as possible and challenge everything. And it would be hard to do that when you have when you're looking at a C code, existing C code, and your main plan is to port this just to Rust. You will drag a lot of C assumptions, a lot of workarounds of C, because each time I talk to C developers nowadays, I realize more and more that when I was doing C as well, most of the time what I was spending time on was working around C limitations. Like how to do async, for example. If you do a lot of async programming, you would know the pain. It's a lot of pain. No matter how easy glib, GIO makes it for you, it's still a lot of pain. You have a lot of callbacks, and then you have to take care of like who frees what and stuff like that. It's like it can become really complicated, really easy, especially if you are doing something complicated as something like a broker that sits between applications and being a bridge that needs to be very reliable and efficient. So a lot of these assumptions I could just get out of and think in terms of a high-level programming language, and to focus more on the problems themselves on a basic level than thinking of how to do it in a particular or very archaic language. So how did I end up with the performance then, right? Like I started, okay, I can do it in Rust, and maybe it will be burst, right? So I did some benchmarking not too long ago with the two implementations, and I compared. So I used a single implementation. So it was basically like transferring a lot of data in single calls with single connections and multiple connections at the same time simultaneously. And I noticed that the performance is almost exactly identical. Actually, funny story is that I did it after somebody filed an issue on BusD that the performance is much worse than dbus broker. What will you do about it? I'm like, oh shit, what do I do now? So I was thinking of a lot of things, and my mind was like going off. What could it be like? What could be making it slow and stuff compared to other daemons? But then when I was doing the benchmarking, I realized something that when I first did the first very simple benchmark, I was compiling with debug on. So it was not compiling with all the optimizations in. It was not including most of the optimization. So it was more optimized for compile time when it was compiling. So when I ran it for release mode, where the compiler's flag, then I got these numbers, which is actually if you look at the multiple connections, it's usually slightly better. We're only slightly, but still a bit better performant than even dbus broker. And there are reasons for it we'll talk about. But yeah, suffice to say that even it hasn't yet developed much, but it's already, and I haven't done any kind of optimization whatsoever, right, like yet. So this is, I think, pretty major without any optimizations. But there must be a catch, right? Why is it so performant like already? How is it so good from the beginning? And that's because zbus is already doing the heavy lifting. So as I said, like well, maybe I didn't say it, but in zbus we have multiple APIs. So as I said, I started like with this first principle kind of thinking. So I started a very bottoms up approach. So I first made sure that we have a really nice, really low level API that does only the encoding and decoding. And then on top of that, more API and more API. And then you have the high level API that you just saw in the code sample. Because of that, I created multiple different kinds of APIs, and one of the middle ground is already pretty efficient because with zbus already saw so much testing, and there were so many issues with regard to all kinds of things, right, including performance. So I did fine-tune already zbus quite a lot. I have a lot of more ideas to really make it extremely efficient, but for now it's already in a good performance level-wise. So because it relies a lot on zbus API, because of that it just inherited that from zbus basically. And because of zbus, we have per connection queues already. If I remember correctly, when dbus broker was new, this was a cool new thing, cool new feature in there, because in C you have to really implement it, right? It's not like you get this out of the box with any C API. They will not even probably think about providing such an API, but in Rust it was just natural to provide such an API. And so when I wrote a BusD from the beginning, I could just implement this without any problem. So one client cannot interfere with the other one. If the other client is slow, that's fine. They have different queues, so it doesn't matter. And also we use this a library called Tokyo. It's async runtime library, batteries included kind of API in Rust, which most Rust projects that need any kind of async, they use it. And it's maintained by AWS people mainly, so they have really fine-tuned it for this kind of services kind of a service kind of stuff. So BusD basically is a service, so it works really nice for it. And because of that, there's not only just per connection queue, but there's also per connection task, which basically translates to thread pools, which also is not so easy to implement and get it right in C. But I got it for free because of Tokyo. So I can just launch tasks and it maintains these thread pools for me, and I am just using really nice async APIs, and that's it. So if you look go now to BusD projects repo and you look at the code, you will find that the code is not a lot at all. It's for something that does already a lot. It's a very small code base. And it's because of this. Also, when we were talking about performance, the multiple connections, you saw that it was slightly better performance already compared to dbus broker. I haven't really done fine-tuned performance analysis. Why exactly is it better? But if I were to make a guess, educated guess, this would be my guess. Separate per connection queues combined with per connection task, which means thread pools. And so it makes use of your cores and your threads on your machine to make sure that things go as fast as possible, especially when you have a lot of clients, which you generally have in a dbus broker. Yeah, thread pools is the reason. Current status, it's MVP, minimum viable product. All the essentials are there. So you can even use it already. And actually, I was surprised to hear that people are actually using it as for some product or something, even though I've said that it's not ready for that. You can't stop people. Anyway, so provides all the standard API of free desktop that's mentioned in the spec. It's already from the very beginning because of zbus and Tokyo being portable, and also because in Rust portability is much easier than C. It supports already Windows, Mac OS, and Linux. Especially Linux is primary target, which it will always be the best, most best supported, I guess. But Mac OS and Windows are also supported. Future goals. I want to have a feature parity with the existing brokers. It's not yet there, but I really want it to be there, and it will be there. It's my targets. And also stress testing. I've just done testing quite a bit. I've done benchmarking, as you saw, but I haven't done really stress tested, so that make sure that it never goes down or something, or goes or whatever. So that needs to be done still. Also some bit of policy. Actually, I've been talking to Lennart about it, and I agree with him that there's a lot of policy configuration in dbus that is really not that much needed. Most people don't really use it, so there's no need for it. So this should be easier to do in BusD, because we will just omit most of it. But yeah, some of it really needs to be still there. And also security related, like check for all kinds of possible issues that can happen. There's actually some testing framework for dbus daemon that Marc-André already sort of ported. There's a work in progress branch here, PR from him that he never completed, but I can complete it, I guess. But yeah, that would make that happen. And also performance tuning. If it's possible, I would like performance to be much better than existing brokers, not just on par with them, which it already is. And I have some ideas about that. Most of this will go in zbus, but yeah, actually all of it maybe it will be in zbus. But yeah, I have some ideas to do that. Sandbox apps, as I mentioned, that's one of the reasons to start this project, so that we have some issues where people have commented on what's needed, especially Sebastian Wick, Mr. Wick, has put it there, like all the information. Someone just needs to do it. Yes, it's slow progress because I started this project last year, maybe even 1.5 years ago. But you have to keep in mind that I've been doing it alone in my spare time, mostly, actually completely in my spare time. I have a small child as well, so it's not easy to find time for it. I tried to get an STF application for it so that I can concentrate completely on this, do this for 1 year, and get it all done, and then in 1 year it's just all there. I had a complete plan for it, how to do it, because that was part of the application process, so that you have to provide a plan and milestones and stuff. But I didn't make it to the last, the last round of it, so I didn't get accepted. Life goes on, but I have now a job where basically we are going to use dbus. So I'm hoping that once things have settled down a bit in the job, I will have more time to work on busd itself, because it would be good to, I mean, I would want my work to use it too, because we don't want to depend on old stuff. And more importantly, you folks can help. It's open source project. Contributions not only welcome, but it's more than welcome. It's like I'm very happy about it if you contribute. I have created the issues that the main milestones that I have in mind, and all the information I could put in there on GitHub. So you can go through those issues. If you find something that you find fancy, you can implement it. And it's a cargo-based Trust project right now, so running it on your system should be super easy. You just get the repo, clone it, and just run cargo run, and you run it. So that's as simple as that. So getting into the project is very easy. Yeah, that's the repo, and that's mostly it from me for now. Any questions? Thank you.
So I guess for the XEG dbus proxy, that's still needed, I guess, at this point. Do you think that's hard to get rid of with the
That
busd?
shouldn't be hard, no. And that is in the plan to when the sandboxing feature that I mentioned, once it's implemented, then XDG proxy can go away, and that would be very ideal. No. Oh, there's one. I knew it. There was a question in your eyes.
So, are you trying to convince one of the distros to use this in the end, or what's the plan there?
That's part of the plan, and that was part of my STF application as well. One of the milestones was to get it into distros, and the way to achieve it is firstly to provide the packages for it. And once there are packages, then it's easier to push for it. And for the starting, it would be much easier to get it packaged and put it in the default repos of the distributions. And once Ubuntu, Debian, and Fedora especially, and maybe Arch Linux and stuff like that, they have packages in their main repos. I think that's the main thing I can work on and I can do. But after that, it's up to them when they switch over by default or not. We can. That's mostly more about. After that, it's more about politics, right? Like how to push for it and how to talk to people to get it done. But I think it also would help to when I have this stress testing and I share the results of it, and to be able to for it to be reproducible, that would be best, so that anyone can see that I'm not making it up. You have a second question? Here's a second question.
It's not a question, but if it helps, we can always put it in GNOME OS.
Sorry?
It's not a question, but if it helps, we can always put it in GNOME OS for testing.
Yeah, well, why not? Yeah, I don't see a problem, because I think once the sandboxing thing is done, then it would be even more. It would make even more sense to put it on GNOME OS already. Yeah. Okay, I think that's it. Thank you so much again for coming, listening to me.